In this video I will show you how to create a simple 2D game in Unreal Engine 5 from scratch. Back in Unreal Engine 4 we used to have a 2D side-scroller template, however this was removed with the release of Unreal Engine 5. So what we built today is meant to replace that and become something you can use as a starting point for many different types of 2D or sprite-based games. I love using Unreal Engine for 2D, 3D hybrid games that make use of the lighting engine to create a very unique look, and what we make today can also be used as a starting point for those types of games. When we launch the browser for Unreal Engine 5, you can see that there are a bunch of starter templates in the Games tab, but as mentioned before, the 2D side-scroller template is no more, so we'll select blank as our starting point. Make sure that it's a blueprint project, set a name, and click Create. When the project is done loading, you can see an open world map, and that is definitely not what we need. In the top menu, click on File and New Level. Select Empty Level and click Create. We now want to save the level, so open up the content drawer by hitting Ctrl plus space. Inside the content folder, create a new folder called Maps. Again, click on File and then select Save Current Level As. Open up the Maps folder we just created and set a name for your map. You can see the map is now saved properly. The next thing we need are some assets for the stage and player character. I'll use the Sunnyland asset pack by Ansimuz, who's an awesome artist that has been providing free asset packs like these for many years. Check the link in the description to download them. Once you have unzipped them, open up the folder and select the PNG folder. This is the only one we care about. You can simply drag it inside the content drawer in Unreal Engine to import them. All of the assets even inside the folder will automatically be selected, which is great because we need to apply some settings. Right click on one of them, click Sprite Actions and apply Paper 2D settings. Then rename the PNG folder to Sunnyland Assets to keep things organized. Let's create a background sprite first. Open up Environment and then Layers. Right-click on the texture called Back, select Sprite Actions and create Sprite. This will create a sprite for us we can actually place in the game world. Just grab it and put it somewhere into the scene. Then reset the X, Y and Z location to 0. Next we want to create a tileset. Right-click on the texture called Tileset, go to Sprite Actions and click Create Tileset. This will create a tileset asset. Open it up by double-clicking. You can now select certain parts of your tileset, but as you can see the selection box is bigger than our actual tiles. We can adjust the tile size in the menu on the right. In this case we want to set it to 16 by 16. Now it perfectly fits the size of our tiles. For things such as the ground, we need to add collisions so our character doesn't just fall through. Select a ground tile and click on Add Box. You can then see and adjust the collision in the right viewport. To also see it on our tile sheet, click on Colliding Tiles. Repeat the process for these other two ground tiles. There are a lot of detailed settings you can do in this menu, but this is enough to get us started. We can then right-click on the tileset asset and click Create Tile Map. This will create an asset we can edit and place in the game scene. We can select a tile from the left as a brush and start drawing the ground. Then just drag it into the scene. And reset the X, Y and Z location to 0. To prevent clipping, we now want to move the background layer back a little bit on the Y axis. One thing to keep in mind is that even when we use 2D sprites and tilesets like these, in Unreal Engine the collisions are actually still happening in 3D space, so keep this in mind in case you run into bugs or strange behavior. Now let's get into the most interesting part, creating our character. Navigate to the Sunnyland Assets folder and open up Sprites, Player. Some characters will come with a sprite sheet where all the frames are drawn into a single texture. In that case you will have to first extract the sprites. I touch upon that subject in a different video which should pop up at the top right now. In this case though, each frame is a separate texture and the way of implementing the sprites is slightly different. Select all textures for the idle animation, right click, Go to Sprite Actions and select Create Sprite. Then select all of the sprites that were just created, right-click and create Flipbook. A flipbook is basically just a collection of sprites that are played one after another to create an animation. The animation is playing a bit fast for my taste, so we'll want to change a few settings here. The frames per second are set to 15, but a good convention is to set this to 60 to make animation speeds easier to calculate. We need to tell each individual frame to be active for 4 frames at a time, which we can set in frame run. This will get us back to the same speed we had with 15 FPS. But we do want our animations to be a bit slower, so let's set frame run to 6. We then do the exact same thing for the run animation. We also want to create a fall animation, however here we only have a single frame. But regardless of this, we still just create a sprite, make a flipbook and set the same values we did before. Now that we have prepared our flipbooks, we want to create our character blueprint. Go back to the content folder and create a folder called blueprints. Right click and create a blueprint class. We need to base our character off of the paper character class, which is not present in the top area. We need to click on all classes to expand the list and search for paper character. This will give us a basic blueprint which has a capsule collision, a sprite and a character movement component attached. First select the sprite and set the source flipbook to the idle animation we created. We now want to adjust the capsule collision to fit the size of the sprite by adjusting the capsule half height and capsule radius. We will also have to slightly change the location of the sprite to match this. Then grab the character blueprint and drop it into the scene. You again want to make sure that the location is zeroed out, so we can land on the collision of our tile map. When we start the game now, it looks like our character isn't quite touching the ground. We'll need to again slightly adjust the position of the sprite until this looks just right. When we set our character position higher in the scene, we can also confirm that gravity is working correctly and affecting the character already. But you can also see that the brightness automatically adjusts when we start the game and looks a bit off. We can fix this by going into Edit, Project Settings. Search for Auto Exposure and turn this off. It now looks a bit better, but it's still not ideal. We will need to set a few more additional things once we attach a camera to our player. Another project setting we want to change is anti-aliasing. Having this set to TSR can lead to strange artifacts with pixel art, so let's set this to FXAA. By the way, if you want to check out what kind of Unreal Engine 2D projects other devs are working on, feel free to join our Discord and hop into the conversation. Now let's add a follow camera to our character. In the Components window, click on Add and search for Spring Arm. While the spring arm is selected, click on Add again and search for Camera. Now rotate the spring arm by a -90 degrees on the Z-axis so that we look at our sprite character from the side. We can then also offset the location upwards a little bit. The camera is a bit far away, so set the target arm length to about 200 on the spring arm. But even when we start the game now, we aren't really looking through the camera we created inside the character, since Unreal doesn't know that we want to possess this character in the first place. It actually automatically creates a different camera for us to control. Let's delete the character and add a player start instead. You will want to adjust the scale of this to be closer to the size of your character. In order to let Unreal Engine know we want to control this character, we first want to create a game mode blueprint from the game mode base class. We then open it up and there's only one setting we actually care about. On the right side, look for Default Pawn Class and set this to our custom paper character. In my case, it's called BP Sprite Character. Go to Edit, Project Settings and click Maps and Modes. Here set the default game mode to our custom game mode we just created. In my case, GM Side Scroller. While we are here, we can also set the default map to our side scroller map. Change both the editor startup map and the game default map to this. When you restart Unreal Engine now or package a game, this map will be loaded by default. When we start the game now, you can see that we are looking through the correct camera that is attached to our character. So let's start fixing the brightness. Back in the character blueprint, select the camera and search for max brightness. You might have to play around with this value a little bit, but what worked for me was a value of 2.0. So we are possessing our character now, but even when we press buttons, it's not moving. We need to again go into project settings and click on input. Add an axis mapping for the movement. Call it move right. To bind the buttons, you can click on this keyboard icon and then press the button on your keyboard or controller. We want to move right when we press D or the right arrow. When we press A, we want to move left, so we need to set the scale value to -1. And then do the same thing for the left arrow button. Now let's add an action mapping for jumping. I will bind this to the spacebar. Inside of our character, we now need to go to the event graph. Here we can listen to the input event for move right. This will basically just give us an axis value between -1 and 1 whenever the player is pressing one of the buttons that we set up. To apply that to our character, we need to look for the add movement input node. Simply connect the execution flow and plug the axis value into scale value. We only want to allow our character to move left and right, so set the world direction for X to 1 and keep Y and Z as 0. The character is now moving when we press one of these buttons, but there is no run animation playing and we don't turn to face into the move direction. Back on the event graph of our character, create a custom event and call it update animation. Drag out a reference to the character movement component. Search for velocity, scroll all the way down and click on get velocity. Get the vector length of this. We then check if the length is greater than 0 and attach a select node. Grab a reference to the sprite and drag off the set flipbook node. Connect the return value of the select node to new flipbook and connect the execution flow. This setup will basically check if our character is in motion and set one of two flipbooks as active. In the false case, we play the idle animation. In the true case, we play the run animation. This will need to be executed on each frame, so we need to call update animation on tick. Now we can see that the animation is playing, but our ground is a bit too small to walk around on. Let's adjust the tile map a little bit. We can set the map width to something bigger, around 30, and then draw in additional tiles for the ground. Now we can test the run animation properly. The next step is to make the character turn around when we start moving in the opposite direction. Create a custom event and call it update control rotation. We can copy paste the character movement velocity from update animation and then break the vector. We only care about the velocity on X and want to compare the float. This can only execute if the character controller is valid, so we can get controller and add a check before comparing the floats. After that, we again want to get controller and execute set control rotation. Drag off new rotator and select make rotator. All of these values should stay at 0. Then copy paste this to the bottom. Here we only want to change the yaw to 180, which will tell our character to move the controller in the opposite direction. This will also need to be executed on each frame, so we need to call it from tick. When we play now, we are turning around correctly. However, it is very hard to see what is going on. Every time we go to the left, the entire character or actor flips around, which will lead our camera to be positioned behind our background, and that blocks the view to our character. In the character blueprint, we need to change one setting on the spring arm. Click on rotation and set this to world instead of relative. This will ensure that the rotation of the character won't affect our spring arm. Now even if we move left, everything looks fine. There is one more setting we want to change on the spring arm. In case an object in the foreground is blocking our view, the spring arm will move forward and zoom in on the character. To prevent this, we will simply need to uncheck Do Collision Test. Let's enable jumping now. Go to the event graph of the player character. Add the input event for jump. When pressed, we call the jump function, which is provided by the character class. On release, we call stop jumping. This is already enough to allow the character to jump. However, jumping still feels and looks really bad. We want to add another condition to our update animation event. Search for is falling. Then connect another select node to it. In the case that we are not falling, we just do the same thing we did before and play the idle or run animation. If is falling is true, we then play the fall animation. This is already looking a bit better. To make the jumping feel better, we need to adjust some settings on the character movement component. First, we want to lower the max walk speed to something around 300. Then set the gravity scale to something around 2.0. Update the jump velocity to around 600. And set air control to about 0.8. Now the character controls pretty decently, but you will most likely have to play around with these values a lot more depending on what kind of game you are trying to make. Another quick adjustment to improve game feel is to let the camera lag behind a little bit and not move instantly together with the player. On the spring arm we can search for lag and check enable camera lag, then set camera lag speed to around 5. This feels very dynamic and a lot more natural, but when you move around a lot now things start to get really blurry because we have motion blur enabled by default. When making a pixel art game, this is probably not an effect you want to have. We can simply turn this off in the project settings. At this point you have a solid base to start making 2D games, so you probably want to create copies of this project and use it as a starting point for your 2D games. From here on out you have to make a decision if you want to make a 2D 3D hybrid game or stick to a simple 2D game. If you want to make a 2D 3D hybrid, you can watch this video I created in the past that will explain how to set things up from here on out. I also have a lot of other videos about making 2D games on my channel, so if you are enjoying this type of content, make sure to check out the videos I made previously and subscribe to the channel. If you don't want to go the hybrid route and just make a simple 2D game, stick around and we'll just polish up a few more things. As you might have already noticed, there are no light sources in our map, but our sprites still look bright. This is because all the materials are set to unlit sprite material, which basically makes textures appear just as they were drawn, regardless of if there are light sources or not. Since our sprites are not influenced by light, we can go into the project settings and turn off lumen to make sure we don't use up any unnecessary resources. Even though we can only move our character to the left or right, it can still be pushed backwards or forwards by collisions or explosions. To prevent this and lock him to the plane, we want to go into the character movement controller and enable Constraint to plane. We only want to affect the y-axis, so set plane constraint normal to 1 for y only. Now even if we try to launch the character forwards or backwards, it won't be affected. Another decision you have to make is if you want to use an orthographic or perspective camera. When we set it to orthographic, depth in the scene will be ignored and everything will look flat, which is what you'll often want with 2D games. This means that even if we move back the background, nothing will change in the way it looks on the camera. The ortho width will make the field of view wider or smaller and act like a zoom effect. A reason why you might want to use perspective camera instead though, is that it allows you to easily set up parallax scrolling backgrounds simply by placing different layers at different locations. The camera will then naturally create that effect. From here on out, feel free to just play around with everything we've learned so far a little bit and create a simple stage you can run around in. Congrats! You should now have a basic understanding of how to make 2D games in Unreal Engine. But as you might have already noticed, the workflow is not as good as it is with many other 2D game engines. However, there are some tools to help you improve the workflow and I made a video talking about these which you can check out here.